Welcome to AWS Fundamentals, Building Serverless Applications. By now, you've probably heard of the buzzword, serverless. Ever wanted to know what that actually means? Ever wanted to know how to build data-driven applications in the cloud as fully serverless? Well, you're at the right place. Hi, my name is Rick, and I'm the technical architect for this course. As the name implies, we're going to focus on building a serverless application. This course won't be just videos. You'll be able to do exercises at your own pace, so you'll get some hands-on experience with our serverless products and services. Although there are tons of serverless offerings from AWS, we only have a few sessions together, and so we have to be a little bit savvy with which services we choose to include. We decided on these: Amazon Lex, Amazon API Gateway, Amazon CloudFront, AWS Lambda, Amazon S3, Amazon CloudWatch, AWS IAM, and Amazon DynamoDB. Now that's an awful lot of content to get through, but don't worry, even if these things are brand new to you, we'll take it real slow. Besides, we have some stellar instructors on hand to help you through each week, along with some fun exercises along the way so you can get some hands-on experience actually using them. So here's how the exercises are designed. Each exercise is going to build a serverless component, and as we progress through the course, each one will tie into the other. This way, the end result will give you a website that touches on everything you've learned. I'm going to ask you to refer to the course notes about how to set up your environment for these exercises. Anyway, I bet you're keen to get started and build a serverless application, right? Or at least find out what serverless means. So before we jump into the lessons, I'd really like you to meet the instructors. This won't take long. Then Wes, and you'll meet him in a second, will introduce what we're going to cover in this first week. Then I'll come back and talk to you about your first exercise of the week. Okay, let's get to know the trainers.
If I wasn't a trainer, what would I be doing? I'd probably be a full-time scuba instructor, living on a sandy beach or a boat somewhere, teaching people how to dive.
I would prefer to spend time at home with my 3 German Shepherds, my husband, and working on renovating my 200-year-old house.
Still be in education in some capacity, whether teaching at a high school or at the college level.
I'd probably still be a trainer like those other guys, because that's an awesome job as well. Not as good as my job.
I love maple syrup. As a French Canadian, I have my own maple farm.
My favorite AWS service is Simple Storage Service, or S3.
It's probably SageMaker.
Route 53.
S3.
Certificate manager.
I really love DNS. I don't know what happened to me when I was young, but I probably fell in the soup of DNS somewhere.
I love being an AWS trainer because I get to meet new people, teach folks how to embrace the power of the AWS cloud.
I think the ability just to travel around and meet our customers face to face and hear about their technology challenges and help them solve real-world problems.
I get to meet new people every week and help them with their technology dreams and their goals.
It's being able to see that light bulb go off and on in the head of our students while you're teaching, and then you know that from this point on they're going to do something amazing.
I get to work in different teams and different projects, so nothing ever gets stale. And it's always really interesting because there's a million different projects going on in parallel. It's a colossal firefight, but it's great fun.
My favorite monkey has got to be the macaw. They're just so clever and good to eat.
So, you just met our instructors. Well, remember Wes? I mean, who can forget Wes, right? Well, he's going to talk to you in a sec about what we're going to cover in week 1. And he'll talk to you about what is serverless and what that even means. But before I hand you over to him, I just want to explain what we're going to cover in terms of these weekly compounding exercises. Now, in my intro earlier, I shared with you which services we're going to cover throughout the whole course. But what I haven't shared with you yet is what we're actually going to build. So, what is the most important, pressing question in our lives today? I know what mine is. It's not what's the meaning of life. It's not how come pizza tastes so great in New York. No, the most pressing question in my life is it too cold for my cat to go out? You all have cats, right? Yeah, you all have cats. Well, if you don't, you can at least pretend you do so you can play along. So this website is just a bit of fun. It's actually a really great way. Even though it is fun, it's a great way to expose multiple services to you that are all serverless. And they're going to build upon each other. And it doesn't take much mental gymnastics to map out some or all of these concepts into actually useful applications. So what I will do is before each exercise, I'm going to have one of the team introduce you to a new core serverless concept, and maybe a demo or two just to touch on some relevant high-level paradigms. Because this will help you hit the ground running when you actually do the exercises. Naturally, I've included copious notes in the exercise guides to help you along. And don't worry if you're not a programmer. This course is introductory level. It's not designed for hardcore developers, although you might get something out of it if you are. But you won't be writing any code. At most, it will be a copy and a paste here and there. By the end, you should have a working cat weather voice-enabled data-driven serverless website. Now, obviously the website itself is just a bit of fun, but our aim is that during this iterative process, you'll actually learn a lot of really cool stuff relating to serverless that you can take out there into the real world. All right, take it away, Wes.
Hi, I'm Wes, and today we're going to answer the question, what is serverless? A serverless architecture is a way to build and run applications and services without having to manage the infrastructure behind it. Your application still runs on servers, of course, but the server management is done by AWS. You no longer have to provision, scale, and maintain services to run your applications, databases, or storage systems. With a serverless architecture, you can execute your code only when needed and scale automatically from a few requests per day to thousands of requests per second. And you only pay for the compute time you consume. There is no charge when your code's not running. You can run code for virtually any type of application or back-end service, all with zero administration. So why use serverless? Well, serverless enables you to build modern applications with increased agility and lower total cost of ownership. Building serverless applications means that your developers can focus on their core product instead of worrying about managing and operating servers or runtimes, either in the cloud or on premises. This reduced overhead lets developers reclaim time and energy that can be spent on developing great products, which scale and that are reliable. So what are the benefits of serverless? Serverless has four main benefits. 1, no server management. There's no need to provision or maintain any servers. There's no software or runtimes to install, maintain, or administer. All of that is taken care of for you. 2, flexible scaling. Your application can be scaled automatically by adjusting its capacity through toggling the units of consumption, for example, throughput or memory, rather than units of individual servers. 3, you pay for value. You pay for a consistent throughput or execution duration rather than by the server unit. And last but not least, automated high availability. Serverless provides built-in availability and fault tolerance. You don't need to architect for these capabilities since the servers running the application provide them by default. A serverless model, therefore, is inherently highly available. So let's get started building your first serverless app.
Hi, John here. I would like to introduce you to chatbots. You may have heard the term before, as they are quite popular these days, and we will see why today. The term itself is derived from chat robot. Why would we need a chat robot? If you think about a chat interaction you may have had with a support team, think how long you waited in line. I don't know about you, but I've had bad experience where I waited for up to 15 minutes until an agent was available. In many cases, what I was asking was fairly simple and could have been executed by asking me a few questions ahead of time. This means that when it was my turn with the agent, I was bogging them down for a few minutes while they couldn't attend to anyone else. The majority of those minutes were spent on the agent asking me questions or redirecting me to another agent for my particular problem. What if instead I could have asked my questions or told what I wanted to do already in the chat ahead of time? Then if I was missing information to complete what I was trying to do, I could I could have been asked a few more questions. So what I'm looking for here is a robot. However, this machine needs to be highly engaging and provide conversational experiences through text or even voice. Okay, so what are our requirements here? I need a bot that can take both text and may send over a chat in Facebook, Messenger, Slack, or via SMS or an audio input. If the input method is text, the machine can start parsing what I have typed. However, if it's voice, the bot needs to take that input and recognize what was said to transfer the audio to text. That's what we call automatic speech recognition, or for short, ASR. Let's take an example here. I would like to book a hotel in Boston for 5 nights. I'm either sending this text as this data as text, or I could also use my voice. So let's add this voice in here. If I was to use my voice, then it needs to be converted into this text that you see at the bottom. I would like to book a hotel in Boston for 5 nights. And that's what automatic speech recognition will do for us. So the voice data plus automatic speech recognition equals to, I would like to book a hotel in Boston for 5 nights. As humans, it's very easy for us to understand what the user wants, that the user wants to book a hotel. We also understand that it's in Boston and then that there is 5 nights. For a machine though, it's a bit more complex. It needs to act as a human to parse that text, to recognize the intent of the text. It needs to deduce what the speaker actually means, and then not just the words that they say here. That is what we call natural language understanding, or NLU. In this case, the bot will need to figure out that it's a hotel that the customer needs. So, in this case, it's a hotel. And figure out that they have already provided information about the city where they're trying to go to. So, this is Boston in this case. And it's for 5 nights. If we were to start a hotel search for this data here, we will need some more information. For example, for which date? This is where the agent has an interaction, a back and forth with the customer. For a human, replying with their voice or text isn't an issue. So if the user used the text to interact with that human, they will be able to reply back with that text. If it was with voice though, it's a little bit different. The human can reply back with their voice. However, for a chatbot, replying with text isn't much of an issue. But if the customer used their voice to do the interaction, the chatbot also needs to reply back with the same modality that was used by the customer in the first place. So the customer, instead of using the chat, will use audio again. The process of translating this text that you see on the left-hand side that the robot wants to send into a voice data, that is what, so this process right here is what we will call text-to-speech. Now, think about our agent example from earlier. That agent will need to ask those questions to the customer and wait for their answer to start that processing. In fact, that agent also needs to ensure that the city, the date, the type of bed are all viable answers. What if the user provides a date that was in the past because the question was misunderstood? Well, that's time that the agent isn't spending with another customer. If we were to replace the introduction of this interaction with a chatbot, it could ask all of those questions to the customer in a conversation and send the data back to the agent that is already validated. It could validate all of the entries from the user and even provide some information back to know if there are availabilities for the dates requested before forwarding it to the agent. This was an example of a call center application. There are many other use cases, like a personal assistant to order groceries or booking medical appointments. It could be used for enterprise productivity where the chatbots can be integrated with enterprise backend systems such as an inventory management program or HR system. They can be built to check sales numbers, marketing performance, inventory status, or perform employee onboarding. In the end, it's a modality of interaction with a machine via text or voice. The three components required for that are automatic speech recognition, natural language understanding, and text-to-speech. This sounds like a lot of work. You'll need to hire some machine learning experts that aren't scared of mathematics like I am to start building all of those three functionalities. Once they will be done with building those functionalities, which will take time, you will finally be able to build your backend processing. Think about the amount of time that this will take. Meanwhile, your customers are waiting for you to provide more options. How can we accelerate this time to build those functionalities? Well, AWS already built those. Have you heard of Alexa? Most know her as the answering voice from the Echo device suite, as you can see here. But she can be heard from many other devices as well. This sounds all great for physical devices, but what we are looking for here is a way to add a chatbot on our website, or maybe in our Slack channel, or even our Facebook page. Well, let me introduce you to a service named Amazon Lex. It provides the advanced deep learning functionalities of automatic speech recognition and natural language understanding that powers Amazon Alexa. So let's add Lex into here. But what about the third functionality here, for text-to-speech? Well, this is solved by using the Amazon Polly service. Amazon Polly is a text-to-speech service that uses advanced deep learning technologies to synthesize speech that sounds like a human voice. As of today, it includes over 50 lifelike voices spread across 28 languages. Now, those are two different services. While Lex integrates with Polly automatically when the user interacts with Lex via speech. It sends this text to synthesize to speech to Polly, which in turn returns an audio file that is then sent back to the user. This means that the barrier of entry for those three functionalities is minimal, as you don't need a machine learning background to develop any of those. You simply use the service with a pay-as-you-go model. In the previous lecture, we discussed what a chatbot is and then learned that Amazon Lex is the service to use to build one. In this lecture, I will demonstrate how to use Lex using the AWS console. Instead of building an entire bot from scratch, I will use a sample. This way, if you want to follow what I do during the demonstration, you can. Let's start at the Lex console. Lex is available in 4 different regions as of today. You can see up all of those regions up here. Let's start with creating the bot by clicking Get Started. You can see 2 main options here, where I can decide to create my own custom bot or use a sample. Let's look at the sample for a few minutes. Here you can see the definition of the bot. I have Book Trip as my bot name. This bot contains something that we call an intent. An intent is a particular goal that the user wants to achieve. So the user sends a few utterances. The utterances are things like, I'd like to book a hotel. So that utterance is sent into the bot. The bot will now look at part of all of its utterances and will try to match it to one of those intents. This time, it's pretty easy. It's the book a hotel intent. Next, we don't have all of the information to be able to book a hotel, so we need to start asking a few more questions towards the user. Well, those questions are sent via something we call a prompt. This prompt, as you can see as sure, in which city, will ask the user for that question. The user will now answer that question by saying, hey, New York City. And then that will fill something that we call a slot. A slot is data that the user must provide to fulfill the intent. There are required slots. And then the bot will need to have the answer to every one of the slots to be able to fulfill this entire intent. Once all of the required slot has been filled, it is now time to ask the user, hey, are you sure you want to book the hotel in New York City? Make sure that we confirm all of those slots that has been filled. If the user answers yes, it is now time to fulfill this bot or fulfill this intent. The fulfillment is the business logic required to fulfill your entire goal, your intent here. So if you have to make a call towards your backend to say, hey, I'm ready, I'm done with the input of the user, I want to send that towards my backend to book my entire hotel. There are two ways to interact with Lex. If you remember our previous lecture, you either send the data as text or you send it as a spoken statement. When you interact with Lex using speech, it makes use of Amazon Polly to convert prompt and confirmation text to speech. This is why Lex requires a role to allow the service to call Polly. Here's a role. We will discuss roles on week 3, so I'm not going to go through it now. The last step to create this bot is to specify if this bot is subject to the Children's Online Privacy Protection Act. In this case, I'm not subject to COPPA. So I'm going to answer no. Let me show you the create your own options here, the custom bot. You can see here a few more options that aren't asked when I use a sample. Don't worry though, all of those options are configurable in the settings of the sample bot. Here we can see the language is set to English. That is currently the only language supported by Lex. Next, we have the output voice option to pick the different English lifelike voice that Polly is going to use. There is another option here called session timeout. This is used to specify how long the information of the user that was passed as session attributes should be kept. I'll go in more details about this concept in a later lecture. Let's go back to booking our trip with the sample book trip bot. I will answer no to COPPA here, and then I'll hit create. Let me explain the editor here. On the left menu, you can see a list of intents. So I have book car and I have book hotel. Below, you can find the slot types. That is a list of custom slot types, which I will discuss later in this lecture. You can also find the error handling section below. Let's take a look at it. In the case where the bot can't match the ask of a user to an utterance in an intent, it will retry twice, as you see it right here, by sending the clarification prompt that you can see at the top here. Sorry, what can I help you with? You can add more prompts and it will randomly select one of them, which makes the bot seem a lot more human. In the case where it can't understand what the user wants to either do by not being able to match it with a utterance in an intent, or when a user doesn't provide a valid answer to a prompt, one of the hang-up phrase will be used. In this case, it's sorry, I'm not able to assist at this time. Let's go back to the book car intent. I will close this prompt here saying that the bot was successfully built, and I'll remove the screen on the right-hand side just so that we have more space here. We have 3 utterance here. You can see make a car reservation, reserve a car, and book a car. You don't need to specify each one of the possibilities, as Lex utilizes natural language understanding, deep learning algorithm to expand those sample utterance. Sometimes, though, you may need to add a few more utterance that the model doesn't associate properly. I'll skip the Lambda piece initialization here because I will talk about it in week 4. Next, we have slots. Let's take a look at the second slot here, pickup date. we see that it's required because there is a check mark next to it, which means that we won't be able to fulfill this intent until this slot is filled. Next, the slot is of type built-in Amazon.date. There are many built-in slot types, and all will start with the Amazon prompt, as you see there. This particular one will take a date entered by a user and transform it to a date that machines can understand. For example, using tomorrow and transforming that to 2019-02-21. A machine can understand that. Then we have the prompt. You can configure what question is asked of the user to fill this slot. Again, you enter a few of them. What day do you want to start your rental? Lex will randomly select one. You can specify the maximum amount of retries as well here, in case where the user enters a wrong entry until Lex returns the hang up phrase we saw earlier in the error handling. Also, you can specify different utterances here that the user may use to answer the question. Typically, those aren't required for simple answers like the date, but sometimes the user may bury the answer into a very long sentence and Lex can't find it. That's where you will add the utterances here. Let's take a look at another slot here. Car type. It is the last slot. Does that matter? Well, the order is what Lex uses to order the different prompts it will ask to the user. So yes, it does matter. The slot type this time is car type values. That doesn't start with Amazon. So it is a custom slot type. Let's take a look at it. Car type values. The slot resolution option is important here. You can specify to restrict values to only the ones you add below. Restricts to slot values and synonyms. You can then add synonyms which will match back to the original value on the left-hand side. If a user specifies a synonym, the actual value on the left-hand side is what will be sent back as the result or as the fulfillment of this slot. So that makes it easier on your business logic. Alternatively, you can configure the slot type to expand on the values. Slot values will be used as training data, and the slot is resolved to the value provided by the user if it's similar to the slot values. There are many slots here. As you can see, there are 5. It seems like there will be a lot of back and forth between the bot and the user to fulfill every single one of those slots one at a time. What if the user was to provide a few or all of the slots via the returns? Well, let's check it out via the book hotel intent to see that example. You can see that the first utterance references some slots this time, nights and location. To do so, you use the curly bracket and the name of the slot in between. Now that means 2 less slots to fill, one with prompts for the user. Isn't that great? When all of the slots are filled, it will be good to confirm with the user that everything that was understood by the model is right. The confirmation prompts provides that. You can see that here again, we are using curly brackets. If the user finds an issue with the answers, they can answer or cancel by saying no, which means we will reply, okay, I have canceled your reservation in progress. At that point, the user will have to start again by invoking the intent via its utterance. If everything is fine, the user confirms that everything is right by saying yes, and then the fulfillment can start. This can either be done via Lambda, which we will discuss later in the course, or by sending back the parameters to the client. Once the client has all of that data, it can be sent to any backend of their choice. Think using JavaScript here. to make an AJAX call with everything that the bot has understood to your business logic. The response section can be used to pass final messages back to the user or even give them the option to move to another intent at the end of our conversation. We've now created our simple bot. In the next lecture, I will modify the bot and introduce you to versioning and publishing. See you there. In the previous lecture, we built a bot from the samples. Now let's do some changes to our bot. But first, you need to understand the concept of versions. Bots, intents, and custom slot types all have versions. So version for the bot, a version for the book hotel intent, and even my slot type has a version here. Why are those versions required? It's to create immutable versions of your bot. You may have a bot version you use for dev, beta, and prod. They may each use a different version of intent, and those intents may use a different version of a slot type. The idea is to make sure that nothing changes once you publish a version of your bot. You can only edit the latest version of each of those constructs. Let's do a change by adding another utterance and save my intent. I'll add book a room. You can see that the version of my intent is still set to latest. The reason for that is that the new version of intents only gets created once the bot is built. First, I'll save my intent at the bottom of this page, and then I will build this intent. Amazon Lex is now building a machine learning model for our bot. This sounds way simpler than doing all of the work myself. No maths required here. This should take less than 1 minute. So with the power of recording, we'll fast forward that a bit. My bot is now successfully built. You can see now that I have 2 versions of my book hotel. Before we move on with the bot versions, let's make sure that this bot is actually working. I can do that using the test bot interface on the right, and I can now interact with my bot either via text or voice. Let's first try by text. Book and hotel in Boston. Whoa, this wasn't part of our utterance. Look at our utterance on the left-hand side. Yes, remember what I said about utterances? They are just samples. And the machine learning model that was built is doing the job of doing natural language understanding. You don't need to think of every use cases. That's why the model is there. You can also see that it detected that I sent Boston as the location below in the summary here. Location, Boston. It's now asking me to fill another slots in here. What day do you want to check in? I will enter tomorrow. Wait, tomorrow? That's not a date. Well, it kind of is. The bot took care of translating tomorrow into a date, as you can see it in the summary where it was translated to 2019-02-21. We now need an amount of night. How many nights will you be staying? 3. The bot again translated the word 3 into the number 3. So it's easier for a backend. Finally, I need to enter my room type. What type of room would you like? Queen, king, deluxe? Let me enter king here. As I love having all of the space in the world in my bed, even if it's just for one in there. You can see that all of the slots have been filled at the bottom of the screen. There's none of them that are null now. The next step is for a confirmation prompt. Okay, I have you down for an amount of night. Perfect, that's what the bot is returning me. I can revise the answers that were sent. Everything looks good to me. Let me answer, go for it. The intent fulfillment has now been executed. And if you remember our choice from earlier, I said to return the data back to the client with what the model has interpreted. You can see all of the data that Lex found. Let's try using my voice this time. I'm going to look at the book car. I don't need to, but it's just for you to follow me. The way that this web interface works is that once you click on the microphone icon, it will start recording. You need to click it again to submit the audio clip to Lex. So let's try it. I want to book a car.
In what city do you need to rent a car?
Wait, it just talked to me. How can that be? Lex only does speech recognition and natural language understanding. It doesn't do text-to-speech. Oh yeah, I remember now. Lex uses Amazon Polly, the service that does text-to-speech. Great. Now that I understand what's happening, let's converse with our bot. Seattle.
What day do you want to start your rental?
The day after tomorrow.
What day do you want to return the car?
On Saturday.
How old is the driver for this rental?
Oh, my age. Well, this is something very strange that happened to me when I hit 25. I just stopped aging. My official documents are just getting more wrong every year. So, 25.
What type of car would you like to rent? Our most popular options are economy, midsize, and luxury.
Mid-size.
Okay, I have you down for a midsize rental in Seattle from February 22nd, 2019 to February 23rd, 2019. Should I book the reservation?
Sure. Great. It sounds like this worked. I'll encourage you to play with Lex a bit more and try a few other utterances. If you see that one doesn't work the way you are expecting it, apply what we have learned in this lecture to add an utterance to get the bot to understand you, and don't forget to build the intent again. Now that we built our bot and tested it to make sure it does what it's supposed to do, it's time to deploy this bot. However, as you can see, it's still pointing to our latest version. I could point my application to this latest version and be done with it. But if I make any modifications, what do you think happens? I'm impacting my users, which isn't great for customer satisfaction. So I want my application to point to a version 1, 2, 3. Wait. That will mean that each time I modify my bot, I need to redeploy my application? That sounds pretty bad. Yeah, that will be. That's why you shouldn't do that. Instead, you should use an alias. Let's see that in action. I'll click on Publish. It asks me to create an alias version or update an alias version. An alias points to a version so that you can still only have one deployment of your code. Let me create a new alias. I'll call that prod and hit the Publish button. This will take a minute or so to publish. So what did I just do? Well, by clicking Publish, it creates a new version, version 1. And then an alias named prod is created pointing to version 1 of our bot. Now that version 1 of our bot points to 2 intents, book car still at version 1, and book hotel, that's now at version 2. Now, I can go in my application and make it point to the prod alias without having to worry about making changes to the bot, as the only way to impact the application will be to publish the bot again and then change the prod alias to point to that new version. That's a lot of mistakes in a row if you were to have that problem. As you can see, book trip has been published. You can see version 1 of our bot right here. It uses version 1 of book car and version 2 of book hotel intent. I'm ready to use this bot in production now. Before we leave, I want to show you the monitoring tab here. It shows metrics over time to understand how your bot is being used and things like latency for the execution of your bot. The other important piece I wanted to show you is the uterance sections here. It is currently empty, which is normal. You can use it to view uterances that your bot did not recognize. Uterance statistics are generated once a day. You can see uterance that was not recognized, how many times it was heard, and the last date and time that uterance was heard. It can take up to 24 hours for missed uterance to appear in the console, and data is typically generated overnight, so don't wait for it yet. From this interface, you can select an uterance that was missed and then add it to your intent. So it is a good practice to review this list when you deploy new intents in your bot. In the next module, you will put to use what you have learned about Lex to do an exercise. Rick is waiting for you. Thanks for watching.
Hi there. Now that John has explained and demoed a simple chatbot, it's your turn. The end goal is to create a chatbot that tells you if it's too cold outside for your cat. Obviously a really important app. Initially though, to get things started, we'll create the world's simplest chatbot that elicits which city your cat's in, and then repeats back to you something like, you want to know if your cat can go outside in Seattle today. But we'll actually stop there and make it answer you a bit later on. But this is a great start as it gets all the plumbing in place for our serverless application. And by the way, working through the console is pretty straightforward. However, I will warn you, the console UI changes all the time. And probably by the time you're watching this, we may have moved things around a little bit, at least visually. So your console might not look exactly like the one you saw on John's screen, but rest assured the concepts still stand and you shouldn't run into any major problems to get it all working. And also, I've added plenty of notes in the lab guide, so I hope that helps. But if you do get stuck, please don't worry. You can always head over to the course forums. So in summary, here's what you're going to do. We're going to create a chatbot that elicits information from you about where your cat is. This, air quotes, conversation may go back and forth for a while, but once Lex has prompted you for all the information that it needs, or what Lex calls eliciting, it will simply confirm with you your request. And once you confirm to Lex that it got the question right, it's going to return to you what we call a fulfillment, basically echoing back what you asked it. And later on, we'll make this chatbot really smart and link it to some other great services like Amazon API Gateway and Amazon DynamoDB. But for now, let's keep things really simple. We'll get the most basic chatbot we can up and running. Okay, you ready? Great. Head over to the lab and enjoy. This is a fun lab.
Greetings, I'm Bobby, and in this course, we are going to learn how to use Amazon's Simple Storage Service, or S3, to host a static website. This is an example of serverless because you don't have to worry about managing the servers or patching them. Amazon's Simple Storage Service is an object storage service that offers industry-leading scalability, data availability, security, and performance. Amazon S3 is designed for 11 nines of durability and stores data for millions of applications for companies all around the world. This means customers of all sizes and industries can use it to store and protect any amount of data for a range of use cases, like websites, mobile applications, backup and restore, archive, enterprise apps, IoT devices, and big data analytics. Amazon S3 provides easy-to-use management features so you can organize your data and configure finely tuned access controls to meet your specific business, organizational, and compliance requirements. When we think about the three number ones with AWS, they are cost-effectiveness, security, and resilience. S3 helps you to meet all of these. I wasn't exactly thinking about alien, more like an earthbound threat, like a DDoS attack. One of the biggest advantages for using S3 is that you can host your website from an S3 bucket and reduce stress on origin or on your actual data center or AWS cloud. This also minimizes your attack surface for your site, adding in an additional layer of security. It's cost effective because it's a frugal method for storage and website hosting, and you're also reducing traffic to your origin site, so you don't have to pay for more web servers by scaling vertically or horizontally. It works to help with your security by reducing your attack surface by not sending traffic to your infrastructure or origin. It's resilient. S3, using the standard S3 storage class, your data is being replicated in the background. We will discuss more about the different storage classes and other options available when you create your S3 bucket for your static website during the demo. Hi, and now I'm going to show you how to use S3 buckets to create a static, serverless website. We've already discussed why S3 is a great option. Now let's do it. I want to clarify that when I say static, I don't mean it can't be interactive. It can. You just can't use server-side processing code like .NET or PHP. You can use a client-side script like JavaScript. In my demo, I'm going to create a website that actually uses JavaScript to show you how easy it is. You can still set up your website to interact with other AWS services like DynamoDB or API Gateway and pull dynamic information by passing variables using query strings. I just bring that up so you are aware that your site can be dynamic, but your processing happens on the client side or using a service like API Gateway. You will learn more about those services later on in this course. To host a static website, you configure an Amazon S3 bucket for website hosting, and then upload your website content to the bucket. This bucket must have public read access. It is intentional that everyone in the world will have read access to this bucket. The website is then available at the AWS region-specific website endpoint. Instead of using the website endpoint for S3, you can also bring your own domain name, such as example.com, to serve your content. Amazon S3, along with Amazon Route 53, supports hosting a website at the root domain. For example, if you have the root domain, example.com, and you host your website on an Amazon S3 bucket, your website visitors can access the site from their browsers by typing in either example.com or www.example.com. For this demo, I'm going to use the AWS console, but you can also access S3 via the command line interface and software development kits. Here we are inside of the AWS Management Console. I can select S3 from here under my recently visited services or type it in using S3. Inside, this is actually going to show all of my buckets. And you'll notice at the top right-hand corner it says Global, which lets me know that these are all of the buckets in all the different regions. You can see I have some in Northern Virginia, Oregon, and Ohio. I'm going to click on Create Bucket. I have to come up with a unique bucket name. So I'm actually going to use my last name and put a 200 behind it. I'm going to go ahead and keep it in the Northern Virginia region. If I had other websites, I could actually just copy those policies here instead of going through everything fresh. But for the sake of this demonstration, we're going to go through each screen. So I'm going to click on Next. Now you'll notice that any time I can actually click Create here at the bottom. It would create the bucket, but we're going to go through and set everything up the way we want it from here. I can choose to have versioning. If you check to turn on versioning, that means if I upload a new index page, for instance, but maybe I overwrote something important, I would always have another version of that that I could have access to. So this helps to prevent against accidental deletes. Not a requirement, something you can or cannot choose to turn on. I can also turn on logging for server access logging. If this were going to be my production website, I may want to set the environment with a tag and say environment equals prod. You can add up to 50 different tags. I could also do object level logging and choose encryption. And for the advanced settings, we have something called object lock, and you can choose to do that for auditing purposes or for legal purposes. I'm actually going to leave everything at the default settings. Again, here's our CloudWatch metrics if we wanted to turn that on. This is important. This is talking about the public access for this bucket, and because this is going to be a website, I'm actually going to uncheck all of these. And I'm also, this is talking about the managing the system permissions. This is talking about allowing S3 log delivery. I'm going to turn that on. It's always a good thing to do logging. I'm going to click Next, and this is basically giving me an overview of my permissions and the different objects, object permissions that I chose. So I'm going to click on Create Bucket, and you can see my bucket here. Otterstein 200 is there. I'm going to click on that. First thing I need to do is go to Properties. Even though I made it open to the public, I want to say that this is going to be a static website, because if I do not, no one's going to be able to get to it still. So I'm going to say use this bucket. I have to identify my index document, which I'm going to stick with index.html. I do have an error.html. If I wanted to have redirects, I could do that. And at any time, if I want to take this site offline, I can always disable that website hosting. So I'm going to click Save on that. Go back to Overview, and now we're actually going to upload our website. So I already have a site that I put together. It's on my desktop. I'm going to just grab those files and choose all of these. And I have JavaScript in there, CSS, my HTML, and I'm going to click Next. And this is important because if I do not change the public permissions to give everyone read access, no one's going to be able to see my website. So I said, yes, I want public read access to these objects. I'm going to click Next. This is talking about the different type of storage classes. So standard is where I know that I'm going to have replication happening in the background within my region in Northern Virginia. For a website, you probably want to stick to standard. If this were being used for other types of storage, something like intelligent tiering or standard and frequent access, those are the options you might choose to be more frugal, but for a website, we're going to stay with standard. I click Next and say Upload. And so I can see the progress happening at the bottom. It's going to upload in a few seconds. It's uploading all those individual images and HTML files. And once it's done, I'm going to click on index.html. I'm going to see that URL, and you will see that my website is going to be live. And it is done. So I'm going to go to index.html. I see here is my s3.amazonaws.com with my bucket name Otterstein 200. I'm going to actually do this in a new window. And this is the website that we just created. So we have my three dogs, the three amigos, Geist, Shot, and Echo. And scroll down, of course, I use this to talk about some of the important factors with Amazon S3. It's got some JavaScript things happening here with the menus. I put it, things my dogs would like. So more steak, please, play ball. But this is how easy it is. And because this website is hosted on S3, I don't have to worry about, is it going to be resilient? Because it is resilient, because it's a managed service from AWS. It's going to be cost effective, again, because it is a managed service from AWS. And it's secure, because it's a managed service from AWS. So this is a great way that I can have a public-facing website and not have to worry about servers in the back end scaling up or down. In the following lab, you're going to have the chance to do this all by yourself.
Hi. As you saw in Bobby's section on S3, setting up a static website is really easy. Well, in this next exercise, you're going to do just that. And the good news is we've prepared a simple website for you already. So all you have to do is upload it to S3 and configure it to act as a static website. And once you do all that correctly, you should be able to interact with the website on the internet, because you will have adjusted the bucket policy to allow anyone to view it. Because remember, it's really important, everything is private by default in S3, and you are going in there proactively to make it available for people to look at with that bucket policy. So once you test it online, we're going to have you make a change to one of the files. And don't worry, it's a very minor text change. We're not going to have you write any JavaScript. But once you've made that change, we're going to update S3 and view those changes. That way, you have experience in uploading and modifying a real live website. And this website, of course, is static, meaning it doesn't hit a back-end server or use a database behind the scenes. But again, this is a really great starting point for a serverless application. Later on, of course, we'll link it to the back end. But for now, let's see how you get on with this exercise. And remember, if you hit a brick wall and something's not playing right with the lab, just jump over to the forums and get some guidance. Best of luck. Welcome to week 2. So what did we learn in week 1? Well, you got to meet all the instructors. So you got to hear John talk about the core concepts behind Amazon Lex, where he built a basic chatbot in the console. And if you did the exercise, you did too. Bobby did an intro into S3 and how to host a static website. I trust that helped you when you came to do yours in the exercise, right? So at this point, what have you actually built? Well, you should have a static website in one hand and a simple chatbot engine in the other. 2 standalone serverless services. Pretty cool for your first week, right? Now, as we progress through the coming week, we're going to introduce to you some more Amazon core serverless services, namely Amazon CloudFront and Amazon API Gateway. We can then, during the next few exercises, start to integrate these services into our website, making it incrementally better and better as we go. I'm not going to talk about CloudFront and API Gateway. I'm going to let Adam and Wes do that. I'll first hand you over to Adam, where he's going to talk to you about our content delivery network service that we call Amazon CloudFront.
Hi there. To start this video, I thought we would do a quick history lesson. Content delivery networks, or CDNs, have been around for quite some time now. Since the late 90s, when the first generation CDNs were introduced to help reduce latency associated with media transfer. Traditionally, static material was retrieved directly from origin each time a user requested it. That took way too long. The CDN reduced that round-trip request time by caching frequently used items at an internet exchange location. Now to the current state of CDN. Amazon CloudFront speeds up content delivery by leveraging its global network of data centers known as edge locations. CloudFront has edge servers in locations all around the world. Let's take a look. CloudFront fetches your content from an origin, such as an Amazon S3 bucket, an Amazon EC2 instance, an Amazon Elastic Load Balancer, or your own web server, and stores it in the edge location. CloudFront can be used to help optimize your application's performance and security while effectively managing costs. We recommend that you also set up Amazon CloudFront to work with your Amazon S3 bucket to serve and protect the content. By design, delivering data out of CloudFront can be more cost-effective than delivering it from S3 directly to your users. When a user requests content that you serve with CloudFront, their request is routed to a nearby edge location. If CloudFront has a cached copy of the requested file, CloudFront delivers it to the user, providing a fast, low-latency response. If the file they've requested isn't yet cached, CloudFront retrieves it from origin, and as an added benefit, data transfer from S3 to CloudFront is often more cost-effective than serving files directly from S3. So it's a win-win. CloudFront also leverages AWS Global Private Network, a separate backbone across the internet that helps bypass worldwide networking issues to provide better performance for both static and dynamic content. To help clarify how this works, let's take a look at the scenario shown in this illustration. We've stored our content in an S3 bucket located in a European region, and we have users located around the world who have access to that content. As the arrows show, whenever a user requests content, the request must go over public internet to the source location, in this case, the S3 bucket in Europe. Depending on the user's location, this can take a long time. Now imagine we set up CloudFront in front of that S3 bucket. Much better. You can see now that there are no longer requests traversing the globe to get our content. Instead, requests are routed to the least latent edge location, that is, the closest in terms of delivery speed. CloudFront then serves cached content quickly and directly to the user nearby, as shown by the green arrows. If content is not yet cached with an edge server, CloudFront retrieves it from the S3 bucket origin. And because the content traverses the AWS private network instead of public internet, and CloudFront optimizes the TCP handshake, the request and content return is still so much faster than crossing the public internet. Let's talk about securing your content. Often companies who distribute content over the internet want to restrict access to documents, business data, media streams, or other content so that only selected users, like paying customers for example, can request that content. By using CloudFront, we can set up additional access restrictions like geo restrictions, signed URLs, and signed cookies to further constrain access to the content following different criteria. Another security feature of CloudFront is Origin Access Identity, or OAI. Let's take a look. OAI restricts access to an S3 bucket and its content to only CloudFront and operations that CloudFront performs. CloudFront includes additional protection against malicious exploits. To provide these safeguards, CloudFront integrates with both AWS WAF, a web application firewall that helps protect web applications from common web exploits, and AWS Shield, a managed DDoS protection service for web applications running on AWS. The goal here is to place layers of protection between your user requests and the data origin, but to do it in such a way that it does not impact performance. AWS WAF lets you control access to your content based on conditions that you specify. For example, IP addresses or the query string on a content request. CloudFront then responds with either the requested content, if the conditions are met, or with an HTTP 403 forbidden error. All CloudFront customers benefit from the automatic protection of AWS Shield standard at no additional charge. I hope that now you're as excited about CloudFront as I am. And as you can see, CDNs are incredibly important to our internet infrastructure and service. In fact, you're probably viewing this course through a CDN distribution now. Now that we've got a good footing on CloudFront, I'd like to show you how to enable this very powerful service in our next video. See you then. Let's get started with the CloudFront demo. First step is I'm going to prepare my content. In this step, I'm going to upload my static content to an S3 bucket. In later steps, we will use this bucket as a CloudFront origin. Amazon S3 is a good choice for Amazon CloudFront origin. That includes static content such as images, videos, HTML pages, .css files, and .js files. The sample image we will use in this tutorial is an image called jingles.jpg. The AWS Management Console is where we will begin in a new browser window. Type S3 in the search box and double-click to open the dashboard. Now that I am in the S3 dashboard, I'll click Create Bucket button. I'll enter a name for my bucket. It must be unique and all lowercase. I'll have the option to choose a region to minimize latency, minimize costs, or to address regulatory requirements based on my data. I'll select Next. On the Properties panel, there are a number of useful options for my S3 bucket, including versioning, server access logging, tags, object level logging, and default encryption. I won't enable these features in this tutorial, so I'll click Next. On the Set Permissions panel, I can set access control permissions for our bucket, but I won't enable these features for this tutorial, so I'll click Next. On the Review panel, I'll select Create Bucket. I'll double-click on my bucket and select Upload. Then add Files, and select the picture of my cat Jingles, and click Next. On the Set Permissions tab, I will need to make my image publicly readable. By default, S3 objects are set to private. I'll change my Manage Public Permissions to grant access to this object. Select Next. On the Properties tab, I can set a storage class option. On the Set Properties tab, I can set storage class, encryption, and metadata. I won't enable these features for this tutorial, so I'll click Next. And select Upload. Step 2 will be entering the CloudFront console. Once my content is uploaded to Amazon S3, I can use Amazon CloudFront console to deliver that content to end users all around the world. Let's get to it. Go back to the management console, and then I will type in CloudFront, select, and I'll select Create Distribution. Step 3 is going to be configuring a web distribution. A web distribution specifies configuration settings so that CloudFront knows which origin to get my content from when a user requests it. I've got a couple options here. I can use an Amazon S3 bucket. I can use HTTP servers, web servers, as an origin as well. I will first choose my delivery option, my delivery method. A web distribution is used for static and dynamic content. Because jingles.jpg is a static image, I'll select Get Started under the web option. I will now configure my settings. In origin domain name, I'll select the name of the S3 bucket I stored jingles.jpg in. I can leave the rest of the configuration settings with the default values for this tutorial. You can learn more about each configuration setting by clicking and hovering over the eye next to each field, just as I've done here. Step 4 will be creating a distribution. Once I've configured my distribution, CloudFront will now create the distribution and propagate it throughout the CloudFront network for me. I'm going to scroll down and select Create Distribution. After this process is complete, the status column will change from In Progress to Deployed. By the way, if you do this at home, it might be a good idea to go ahead and grab a cup of coffee. Luckily, I have my friends in the studio who are quite adept at time travel. So on this video, step 4 goes very quickly for me, but for you, it can take up to 15 minutes. The domain name that CloudFront assigns to my distribution appears in my lists of distribution. I will need to make note of this for the next step. Clicking on the distribution ID field takes me to a page where I can see the full CloudFront domain under domain name. The next step is to test my link. After I create my web distribution, I can test it out by confirming that CloudFront gets my object from origin and returns it into my web browser. For this test, I will need the CloudFront domain name from step 4 and the image name I uploaded to the S3 bucket previously in step 1. I'll open a text editor on my computer, copy and paste the following HTML code. I'll replace the domain name with the domain name that CloudFront assigned my distribution. I'll replace object name with the name of my image file in the Amazon S3 bucket. In my case, it's jingles.jpg. I'll save the text file as mycloudfronttest.html. I'll open my web page in a browser to ensure that we can see my content. And there you have it, a cute cat. Step 6 is to disable my distribution. I can easily disable the distribution from the CloudFront console. In fact, it's a best practice to disable distributions that you are no longer using, so you don't keep getting charged for them. However, note that when a distribution is disabled, any website supported by that distribution will be down and the content will no longer be accessible to the end users. I'll select the checkbox next to the distribution I created and click Disable. I'll be asked to confirm and then I'll click Yes, Disable. That's it. How easy was that? Now you can go and create your own low latency static site to serve up as many cute cat pictures as you can possibly handle. That's all for now. I'll see you in other topics.
Hiya. You heard Adam's explanation of our content delivery network, Amazon CloudFront? Well, he touched on the idea that in order to provide low latency for people viewing your website, we need to bring the content closer to your users. and alleviate that direct load on those origin servers? Well, we want to take advantage of this cool concept with our website. Now, in our case, we're using S3 to host our website, right? Well, we don't want to have some users visit our website directly at S3 and other users visit it indirectly via a CloudFront distribution, because that's going to get really messy and your server logs, well, they'll just be confusing. So we're going to use a CloudFront distribution in front of our website. What are the steps? Well, step 1, we're going to make your S3 website private again. Yes, that's right, all that bucket policy stuff you did to make it available to everyone, that's going away. We're going to replace it with something that's much better. We're going to adjust that bucket policy so that our website is basically saying, I'm only going to be communicated with by a very specific CloudFront distribution. In this case, the one we're going to have you create. That way, what we're doing is we're forcing all the traffic to be served through CloudFront, and that's exactly what we want. You know, I think you'll be pleasantly surprised with how easy all this is to set up. CloudFront is a very powerful service, and we have customers using it to serve millions of requests. And as Adam alluded to earlier, there are tons and tons of advanced features available for you to use. And the good news is, you're only going to have to set up a very, very basic distribution for this exercise. It's all we need. Okay, off you go. Set up your global website. Good luck.
Welcome back. I'm Wes, and in this section we will introduce Amazon API Gateway. We're going to do a quick overview of what the service is all about. We'll talk about why you would want to use it, and then we'll run through a quick demo to show you how to create and configure your very own API Gateway in the AWS console. Let's get started. So API Gateway is a fully managed service that's designed to make it easy for developers to create, publish, maintain, and monitor secure application programming interfaces, or APIs, at any scale. With a few clicks in the AWS Management Console, you can create REST and WebSocket APIs that act as a front door for your applications to access data, business logic, or other functionality from your backend services, like workloads running on EC2 and web applications. API Gateway also provides an easy interface for code running on AWS Lambda and other AWS services, which we'll discuss in detail later in this course. First off, why would you want to use API Gateway? Well, it turns out that software development organizations are moving more towards microservice architectures. Microservices are an approach to software development where software is composed of small, independent services that communicate over well-defined APIs. These services are in turn owned by small, self-contained teams. Microservices architectures make applications easier to scale and faster to develop. And that really enables innovation and accelerates the time to market for new features. API Gateway fits right into this scheme, so why would you want to use it? Well, developers can add headers, map input variables from post events to something your target application needs. You're going to see this in the demo in a minute, as well as later in this course. Here are several more reasons you might want to use API Gateway. Efficient API development. You can run multiple versions of the same API simultaneously with API Gateway. This allows you to quickly iterate, test, and release new versions. We're talking about the difference between days and weeks. Easy monitoring. You can monitor performance of metrics and information on API calls, data latency, error rates from the API Gateway dashboard, which allows you to see millions of requests in a single pane of glass. Performance. You can provide end users with the lowest possible latency for API requests and responses by taking advantage of our global network of edge locations using Amazon CloudFront. You can also throttle traffic and cache the output of API calls to ensure that the backend operations withstand traffic spikes and backend systems are not unnecessarily called. Cost savings. API Gateway provides a tiered pricing model for API requests. You can decrease your costs based on the number of API requests you make per region across your AWS accounts. Flexible security controls. You can authorize access to your APIs with the AWS Identity and Access Management, or IAM, as well as Amazon Cognito. If you use OAuth tokens or other authorization mechanisms, API Gateway can help you verify incoming requests as well. By providing an extra layer in front of your backend service, you can add extra layers of protections and security as well. So enough marketing speak. Let's crack open the AWS console and show you how this thing works. So in this demo, we're going to log into the AWS console, go to API Gateway Service and get started. There's a little note there about an example API that's already set up for you. However, we're going to create a new API by selecting New API. We're going to get it a name. In this case, we're just going to use Demo. The description itself is optional. And we hit the Create API button. In our actions, we're going to create first a new method. And for this particular demo, we're going to make it real simple, and we're just going to use a GET request. As part of this GET request, since this is just a demo, we're not actually going to do anything. We're going to use, for the integration method, we're going to use mocking. And what mocking really is, it's just a fake way to send some information and bounce it back without actually making anything happen. So we haven't written any code, we don't really have a service, but we want to test that the API Gateway works. So in this particular case, we have created our method request. We've decided that our integration request type is going to be mock, and again, that's just for fake. So the next thing we have to do is the integration response. And the way we do that is selecting integration response. We're going to scroll down and expand this, and we're going to simply use a mapping template that's already been created for us. It's application JSON, and the little drop down here, we've got our method pass-through. This code's not super important, but all it really does is bounces back any request that's sent to it with all the information that's coming through in the header within the request. Check it out. We save our particular request, and now we are going to deploy it. Go back to Actions and hit Deploy API. We're going to give the stage a name. In this case, we're just going to call it Test. Call it a new stage. We're going to call it Test. And we don't have to give it a description. As you'll see, since I've created this, we now have a URL. I can click on this URL to test my API. All we've done is gone out, we've taken all the information that came from that particular request, the header itself, and you can see all kinds of information in the query string that was returned, all the variables, my IP address, and all the browser information that was returned. It's really just that simple.
Hi. So Wes has talked to you about API Gateway, and specifically how to set up a mock API. Want to guess what you're going to do in this lab? That's right. You're going to mock an endpoint using, surprise, surprise, API Gateway. This concept is often used by developers as they are building out their web apps, because they might have to develop on the front end first, but might not be ready to wire up, say, a database at the back end. A mock is great for this kind of thing, as we can wire up all the plumbing for the website to communicate to a real back end, but actually just receive dummy data back. Once your mock's in place, you can have a working front end and kick that back-end intelligence down the line. Worry about that later on. So are you ready to mock out an API? Well, thanks to Wes and his demo, this exercise should be a breeze for you because you're following exactly the same steps. You'll log into the API console, so at this time you'll create a post method, as our front end will send a payload of city, and hardcode the mock to send a fixed temperature back rather than echo the whole request back like you saw in Wes's example. That's it. We can worry about replacing the mock with real functionality a little bit later on. There's one other thing. Cross-origin resource sharing, aka CORS. This one's a pain. You see, when a website makes a request via JavaScript to a back-end API, such as the one we're having you create, the browser will complain and not allow the data back into the browser if it thinks it's not coming from your server, i.e. cross-domain. But why would it think it's cross-domain? Well, it turns out that because your website is hosted, or at least served from, CloudFront, and thus using a CloudFront domain name, the browser thinks, we're at one domain for this site, yet JavaScript from this site is trying to call a different API gateway domain name. That doesn't smell right. You know what? Let's just block it and play it safe. Ta-da, broken website. So how do you get around this? How can we inform the browser that we actually manage that API endpoint as well? In other words, we need to say to the browser, it's still ours, please let this request through. Luckily, there's an easy fix. We leverage a feature of API Gateway Console that hides the complexity of manually setting up and configuring CORS. It's literally a button that says Enable CORS. Just press it. Let API Gateway add all the technical stuff behind the scenes in your API, and that way, from your perspective, it just works. Problem solved. So, in this exercise, you're going to do two things. One, you're going to create an API gateway using POST with hard-coded mock data. And two, you're going to press that Enable CORS button. You'll know when you've got CORS enabled correctly because your website will work. Remember, forums are your friend. Go there if you get stuck. Welcome to week 3. So what did we learn last week? Adam talked about our content delivery network, Amazon CloudFront. And the first exercise of last week was to put one of those CloudFront distributions in front of our S3 website, so that we have a website that is globally available with low latency for our users. Awesome. What did you do then? Well, thanks to Wes explaining API Gateway mocks, you should have been able to mock out a backend for the website and test it, right? So all in all, what do we have so far? We have a low latency website that actually hits our own backend, albeit a mock, and returns a temperature. Pretty good progress, especially as we're only in week 2 and we're already implementing multiple serverless services. So what's next? What does evil Ricky have in store for you this week? Lots. Amazon DynamoDB, our serverless NoSQL database. Amazon IAM, Identity and Access Management, the overarching system that determines who can do what when. And most people's favorite service, AWS Lambda, serverless functions in the cloud. Now that's a lot of stuff to cover in 1 week. Please don't worry, you're in great hands. Bobby's going to discuss IAM, Adam will talk about Dynamo, and I'm afraid, sadly, you're stuck with John for the Lambda sections. Just kidding, we all love John, he's great. But as far as this week's exercises go, I want us to swap out our API Gateway mock for a function mock, so you get some hands-on experience actually using Lambda. In fact, we're going to use Lambda a lot throughout the rest of this course. So I think I'm going to have John and Adam start off this week discussing the pros and cons of Lambda and serverless in general. And I'll see you again just before the first lab.
Hi again. I want to talk to you now about Identity and Access Management, or IAM. Later this week, you will see how roles are used to allow services like Lambda to work. So let's talk about roles. In AWS best practices, roles are generally the right solution. They allow us to give access to third parties without creating a new IAM user. This is great for service accounts or application IDs. Let me give you an example. In the Unix world, if someone told me their user ID didn't have permissions to perform a specific task, I would use the su command or switch user to log in from my root account to their user ID to see if their user really didn't have access to perform a command, or perhaps it was just a syntax error on their part. Although I had root or super admin rights on a system, when I use the su or switch user function, I assume the privileges of that ID. Let me give you another example. When I assume my role as a fireman and I have on my turnout gear in the fire truck speeding to a house fire and pass a police officer, he isn't going to stop me and give me a ticket. In my role as a fireman, I'm allowed to speed to the house fire. However, when I get back to the station, off duty, take off my turnout gear, and get into my personal car, if I speed past that same police officer, he's going to give me a ticket. In my role as Bobby, private citizen, I'm not allowed to speed. I'm the same person with or without my turnout gear, but in my role as a fireman, I'm allowed privileges that I'm not afforded as a private citizen. An IAM role is an IAM entity that defines a set of permissions for making AWS service requests. IAM roles are not associated with a specific user or group. Instead, trusted entities assume roles, such as an IAM user, an application, or an AWS service like EC2. IAM roles allow you to delegate access with defined permissions to trusted entities without having to share long-term access keys. You can use an IAM role to delegate access to IAM users managed within your account to IAM users under a different AWS account or to an AWS service like EC2. To get started with any IAM role, you just need to create the role similarly to the way that you create a user. Name the role and attach a policy or permissions to it. You assume an IAM role by calling the AWS Security Token Service or STS. You can also use the Assume Role APIs, Assume Role with Web Identity, or Assume Role with SAML. These APIs return a set of temporary security credentials that applications can then use to sign in requests for different AWS services or APIs. There is no limit to the number of IAM roles you can assume, but you can only act as one IAM role at a time. When should I use a user versus group or role? An IAM user has permanent long-term credentials and is used to directly interact with AWS services. A group is primarily a management convenience to manage the same set of permissions for a set of IAM users. So for instance, I would want all of my DBAs or database administrators in the same DBA group, so that if I have a new DBA come on board, I can simply add him or her to that group and know that they have all the privileges they need to perform their job as a DBA. An IAM role is an entity with permissions to make AWS service requests. IAM roles cannot make direct requests to AWS services. They're meant to be assumed by authorized entities such as an IAM user, an application, or AWS services like EC2. Using IAM roles to delegate access within or between AWS accounts. There's a soft limit of 1,000 roles per account, but because this is a soft limit, you can request an increase in the number of roles for your account. For troubleshooting purposes, keep in mind that there is an implicit denial for all actions. IAM policies are evaluated along with the service's resource-based policies. When a policy of any type grants access without explicitly denying it, the action is allowed. Meaning, if I have anywhere in the policy an explicit deny statement, that will override any allow statement. For more information on IAM, go to the documentation located at www.aws.amazon.com/IAM.
John and I have this awesome web application we're looking forward to deploying soon. But we've been debating back and forth about which deployment approach is best because we're not really sure if it's going to go viral or not. But we'd like to be prepared for it.
You may have heard about the Hello World application. In fact, mostly everyone in IT has heard about it. The issue with that application is that it's boring and it's static. Instead, we want to create the Hello World version 2 application. This application shall take a name as an input, John, and then she'll reply back with hello, whatever that name was, in this case, hello, John. Since everyone in IT knows about Hello World, I'm pretty sure it's going to go viral.
Let's certainly hope so. Okay. I think the traditional deployment method is probably our best bet. 1, I know it. 2, it's tried and true. 3, I could show it to you in just a few minutes.
Well, I'm pretty sure serverless is the right approach, but if you want to show me architecture, go for it.
Okay, well, let's get to work. Okay, John, let's check out my architecture. All right, so I've got a VPC, and that provides me logical isolation at the network level. I have an internet gateway, which allows inbound and outbound traffic. I have an ELB, which distributes the traffic across 2 availability zones. I've chosen 2 for high availability and fault tolerance. And then I have 2 EC2 instances. The ELB will distribute the load to those, and I'll show you the flow of traffic now. So traffic comes inbound through the internet gateway to the ELB. And then is distributed to the EC2 instances. So what do you think?
Wow, that was a lot for a simple Hello World application. Let me show you a different way of doing this that is a bit simpler. API gateway is going to receive traffic from the user. It will send that traffic into Lambda, and Lambda will be replying back with that traffic all the way down to the user. And that's it. Wasn't that much simpler? Adam? Adam, you there? Clearly, Adam is in agreement that this is the way to go. So let me discuss Lambda since you already know API Gateway. At this point, you have learned about different serverless services. However, the category of serverless I want to discuss with you today is compute. AWS Lambda is a serverless compute service. It lets you run your code without provisioning or managing servers. You pay only for the compute time you consume. That means no charge when your code is not running. In our example here, if there are no users that sends requests, there are no charge for Lambda, and there's no charge for API Gateway either. It also means that you don't need to wake up in the middle of the night to respond to a server that crashed or do patching outside of business hours. With Lambda, you can run code for virtually any type of application or backend service, all with zero administration. Just upload your code and Lambda takes care of everything required to run and scale your code with high availability. With AWS Lambda, you pay only for the requests served and the compute time required to run your code for each of those requests. Billing is metered in increments of 100 milliseconds, making it cost-effective and easy to scale automatically from a few requests to thousands per second. Building serverless application using Lambda means that developers can focus on their core products instead of worrying about managing and operating servers or runtime. This reduced overhead lets developers reclaim time and energy and can be spent on developing great products. Customers do care about the availability of an application, but what they really want to see are new features. So with Lambda, you can focus on those new features. In the next lecture, I'll go in more details about how Lambda works. Thank you for watching. In the previous lecture, you learned about the benefits of Lambda. Let's dive into the details. Before you can start creating the code of your Lambda function, you will need to pick a programming language. As of today, Lambda natively supports 6 programming languages: Node.js, Python, Java, C#, Ruby, and Go. Sometimes those native runtimes aren't enough because you may have a tool that you don't want to rewrite that's in C++, or maybe because your expertise is in PHP. That's why it's possible to use your own runtime, but you will need to develop that piece as well. Now that we figured out the runtime, the next step required to create a Lambda function is to upload our code. That can be done in 3 different ways. You can use the inline code editor, upload your own zip file containing your code, or decide to store that zip file in S3 and point Lambda to that file. Depending on what your code does, you may require Lambda to access other AWS services. For that, you will need to specify an identity and access management role that Bobby will explain to you in the next lecture. That role is required to do logging, as an example. That's right, you aren't getting away with no logging here, as you may need to troubleshoot the execution of your Lambda function. To do so, you can just output to the console in Node.js and Python. Anything that is sent there will automatically be sent to the CloudWatch log service, which is just a service to collect logs. That's why the permission of your Lambda function are so important. At that point, the Lambda function will be created. However, a Lambda function on its own doesn't do much. It needs to be executed. We call that triggers. There are many AWS services that can trigger a Lambda function. Some that we have already seen this week that can trigger a Lambda function, like Simple Storage Service, CloudFront, API Gateway, but there are many more. For example, a Lambda function can be triggered by S3 when a new object gets uploaded. So if you wanted to transform a picture that is uploaded to an S3 bucket, and flip it upside down towards another S3 bucket. Let's take this example on a diagram. On the left side of this diagram, you can see an S3 input bucket with a triangle. And then on the right-hand side, I have my S3 output bucket with that same triangle flipped. In the server world, you will have to pull the S3 bucket to know if a new image has been uploaded every once in a while. So adding my server here, I'll need to pull that S3 bucket constantly until that image is there. And then once I'm ready, I can then send that towards the other S3 bucket. While with Lambda, you can configure S3 to trigger the Lambda function as soon as that image is uploaded. S3 needs to be allowed to trigger your Lambda function, as by default, nothing can trigger it. To do so, you use a function policy referencing the S3 bucket, in this case, our input bucket. Luckily for us, if we use the AWS Management Console, that policy can be automatically created, as you will see in the next demonstration. When your Lambda function gets executed, Lambda, the service, needs to know what piece of your code it needs to execute. That is the entry point for your code. In the Lambda world, that's called a handler. This tells Lambda in which file or class the function to execute is, as well as its name. Lambda will use that handler to execute your Lambda from the trigger it received. But your code probably needs to receive some more information about what just triggered it. That information is passed to the handler via what we call an event payload. If we go back to our example of a picture uploaded to S3 to be transformed, that event payload will contain the bucket name and the object key of the blue triangle, which Lambda can now use to know which one of the objects from that input S3 bucket to transform. When a service like S3 invokes the Lambda function, there is no need for S3 to get return data from the function. It really doesn't care about what Lambda does. That is what we call an asynchronous invocation. If we take another example where we will have API gateway that sends a request to Lambda for a REST API call. API gateway is really interested in the response from Lambda to be able to send it back towards the user. That is what we call a synchronous invocation. Those are the two types of invocation of Lambda. While the function is running and transforming that image from S3, RAM and CPU are used. How are those allocated in Lambda? Well, you don't allocate CPU power, you only allocate RAM. However, the more RAM you provide, the more CPU power your Lambda function will also have. As of today, that RAM allocation can go from 128 megs to 3 gigabytes. Why will you not always allocate the highest amount of RAM? Well, the reason is that you pay more money per 100 milliseconds when you allocate more RAM. So that's obviously more expensive. Let's not do that. But wait. If the Lambda function finishes in less time because it has more RAM and CPU power, then it means that it uses less 100 milliseconds, thus reducing the price of the length of our Lambda function. Let's take a look at a graphic here. What you can see here is Lambda compute cost by function execution time for 100,000 invocations. On the y-axis, you can see the cost of compute from $0 to $12 USD. That is not that expensive, but yeah, this is Lambda. On the x-axis, I can see the function execution time in milliseconds. So in orange, for example, at the 3-second mark, what I can see is that for a function that will have 2 gigs of RAM, it will cost close to $10 for running that for 3 seconds for 100,000 invocations. For a 512 megs of RAM, it will cost a lot less, so about $2.50 or $3 here. Well, then you will always be using the lower amount of RAM. No, but let's think about this for a second. if it takes 3 seconds to execute our Lambda function with 512 megs of RAM, how much time will it take to execute that with way more horsepower here? Well, I don't know. It's not always a function of this. It's not division in here. So maybe it will arrive towards 400 milliseconds. So if you look at the price difference, now we're at about, I don't know, about $1 here versus executing that at the $2 to $3 mark that is here. So since this all depends on the complexity of your Lambda function code, you will need to execute some tests to figure out which amount of RAM is better here, which is the lower cost. Now, a limitation of Lambda is that a single execution can only run for a maximum of 15 minutes. After 15 minutes, we will yank the carpet under your code and it will now have no choice but to stop abruptly. If you do need to run for more than that, you are probably looking for another type of compute. Staying in the serverless world, you could take a look at AWS Fargate, or you could go to an architecture like the one Adam talked about with those servers. Since you pay per 100 milliseconds of your code running, and Lambda has a maximum timeout of 15 minutes, what happens if your code was to go in an infinite loop? Will you be charged for all the way to those 15 minutes? The answer here is yes, you will. However, there is a timeout that is configurable for your Lambda function to prevent this kind of behavior. In the next lecture, I will do a demonstration of all of the topics we just covered using the Hello Name application we discussed with Adam earlier. Thanks for watching. So now that you have learned a lot about Lambda, but all in theory, let's put it to practice. In an earlier lecture, I told you about that brilliant application of Hello Name. So I want to use this time and do a demonstration about that Hello Name application. If you don't remember it, don't worry. Let me re-explain it to you. The idea from it is I want to go to www.example.com/?name = John. And then that is supposed to reply with hello John. So the architecture that you've seen from our previous lecture was that API gateway was the endpoint of this www.example.com, sending that into Lambda, and then Lambda, when it needed to, was sending its logs into CloudWatch logs. That was the whole architecture. So for this to work right now, the first piece that we need to do is to create an identity and access management role. Why do we need that? Well, this role is going to be applied to our Lambda function because Lambda needs to be able to send its logs into CloudWatch logs. So that's the first step that I need to go and do. So join me into the console. First, I am into the Identity and Access Management console under the roles, and I'm going to create a brand new role. This role is going to be for Lambda, and then the permissions that I need, I'm going to use an already built policy that comes with your account that is called the AWS Lambda Basic Execution Role, which gives us write access into CloudWatch logs. Don't forget to click that little check mark button that is right there. And I'll click Next on tags, which are optional, so I'm not going to go through them. And then in the review, I need to specify a name. We're going to call that the Lambda Basic Execution Role and create this role. Now that my role is created, I can go and create my Lambda function. So let's go into the Lambda console, click the Create a Function button. I'll author it from scratch. I won't be using any blueprints or serverless application repository here. So I will give it a name called the Hello Name Lambda function. And then now I need to select a runtime, the language I will want to use. Obviously, I will be using Node.js because that's my favorite language. And then I need to specify a certain role. Well, the Lambda Basic Execution role that we have just created into the IAM console a few seconds ago. I'll hit Create this function. Let me explain to you this console that is right here. First part is the designer that you see at the very top. This designer makes everything work inside of the Lambda console. if I click on different buttons that is inside of this designer, the bottom of the page changes as we move along. So if I click on this view permission, at the bottom of the page, I now see the function policy and in my execution role that I have just created. If I go back and I click on this hello name piece that is there, which is my Lambda function, now I can see my code of my Lambda function. Yes, this is how the designer is actually working. On the left-hand side, I can define triggers for my Lambda function, what will call the Lambda function itself. And then from the Lambda function, what it has access to are what you see on the right-hand side. CloudWatch logs is the only thing that my Lambda function has access to right now. Now, let me scroll down into that function code. I have the code entry, 3 methods, upload a zip file via S3, or edit the code in line. Today I'm going to use the edit the code in line. Then my runtime, Node.js, and then I have a handler. This handler is what tells Lambda, the service, what to call inside of your code. It says call the index file, index.js file. So if I look on the lower left, I have the index.js file. And then call the handler function. I have an export of a handler function. That's how Lambda will call my Lambda function. Now, inside of this code, I have a status code of 200, which means an OK status, that everything has worked. And I have the body which says hello from Lambda, and that response is being returned by this handler. So that's what we return back depending on the event data that is being sent into my Lambda function. So what I really want here is to change this hello to be a hello John. That's what I want to send. So I'll save this function and I'll test it. When I click the test button, I need to configure an event data that will be sent into Lambda. So I'll give it a certain name, hello name test. I'll pass in a certain parameter, name, and then the value is going to be Jonathan. And I'll create this test. Then execute it. Now my execution, if I scroll back to the top of the page, I can see the execution succeeded. It's in green. If it was in red, then I will have had a problem with my test itself. Let's take a look at the details. It says status code 200, and the body says hello John. Isn't that supposed to say Jonathan? Let's go and take a look at the code. Oh yeah, I've hard-coded the value of the name inside of my code. I'm not supposed to have done that. I need to take the data coming from the event payload. So let me remove that piece in there, and I'll add event.name. From the event variable, I am going to have a name parameter sent into it. I'll save it and test it again. And this time, I can see hello Jonathan. Other piece that I can see from within this console is I can see the duration of this Lambda function. It only took 28 milliseconds for it to execute. And I got billed 100 milliseconds. I used 71 megs of memory out of 128 megs of memory that has been assigned to this Lambda function. Scrolling down in the page, in the basic settings, I can see that this is where I can specify my amount of memory for this specific Lambda function, which also controls the CPU, the amount of CPU power that I get, and as well as the timeout, the maximum amount of time that I want my Lambda function to run. So the next step into here that I wanted to show you is logs, right? So Lambda is supposed to be able to execute and call and output logs. So let's go in our code and add certain logs into here. I'll go into this and remove that to implement, and I'll output a certain log statement. One of the good things to output in your logs is the event payload, to be able to troubleshoot that a little bit later. So I'll pass in event, and then I'll use the JSON.stringify function to take the event payload that is passed as a JSON input and then stringify it. Right? I create a string from it, and then that will be what will be logged in there. I'll hit save on this and test it one more time. Now, I want to go and look at those logs. Let's go and take a look. I have the configuration tab right here. This is what we've been playing with all along. But if I go into the monitoring tab, there's a whole new dashboard that gets executed here. In here, you're going to find that I have invocation count, how many times I've invoked this. You'll find the duration of my Lambda function, and you also find the errors. It seems like there is 0 errors for this Lambda function that I have executed. So my Lambda function is working. At the top, I also find the View Logs in CloudWatch button. So if I click that, the CloudWatch Logs console opens. I can see now that I have a certain log stream that got created for me. So there are 3 log streams. Why is that? Well, every time that I change my Lambda function, a brand new container gets deployed, brand new Lambda function gets invoked in there, which means there will be a brand new log stream that gets created. I changed my code 3 times, hence why I see 3 log stream in there. The last log stream is the 1030 log stream right here. So if I click on it, what I am going to find in there is the start of my Lambda function, and then I have the event colon my payload. So the name Jonathan that was sent as part of my test. So this is how you can do troubleshooting with Lambda. Lambda is using console.log, or any print output in Python, for example, will be sent into CloudWatch Logs, and you can go and review them inside of CloudWatch Logs. Let's go back into our diagram. So at this point, we've created everything on the right-hand side, from Lambda to CloudWatch Logs. In the next video, I'm going to integrate API Gateway into this architecture, where this www.example.com/name=John is going to be sent into. If you have the time, you can follow me over there. In our previous lecture, I've introduced to you Lambda, or the demonstration with you of Lambda with CloudWatch Logs of this example.com application. The next piece that we need to integrate in here is API Gateway. So API Gateway is going to receive a request. This request is going to be on the /resource, and it will be a GET request with a query string parameter of name being passed in. So let's go into console and go and take a look. In the API Gateway, I will click the Get Started button, which will say, hey, do you want to create an example API? Not really. I want to create a brand new API. I'll give it a name called the Hello Name API of type endpoint regional. I'll create that API. Now, in my resources, on the /, I'll create a new method that will be of type get. And I want this get request to send the data into a Lambda function that is called the Hello Name Lambda function. I am also going to make use of the Lambda proxy integration. The Lambda proxy integration automatically takes the input request, packages that into a JSON payload, and send that into Lambda. We may have to do a few tweaks into a Lambda function to adapt for this type of payload being sent in there. But first, let me save this setup right here. When I hit the save button, it says add permission to Lambda function. Yes, API Gateway needs to have access to call that Lambda function, but only your API Gateway needs to have access to it. So before I click the OK button, I want to go back into my Lambda console and then show you the current permission of this Lambda function. So I'll click on that View Permission button right here, and then I can see under the function policy that this Lambda function's policy is empty, which means no one is allowed to invoke this Lambda function unless they have IAM permissions. Well, let me go back into the API Gateway console and click the OK button. I'll go back again into the Lambda console, hit the refresh button, click on that View Permissions, and I can now see that API Gateway has access to call my Lambda function, my resource is right here on the right, hello name, if the source ARN is QAE, ends with QAE, and get request. Let's go in API Gateway. I can see QAE and then the GET request. So only my API gateway that I have just created is allowed to invoke this Lambda function. That's why this ARN is very important to have inside of your function policy. So you can always let API gateway do that for you automatically, or you can do that manually yourself. So the next step here is the method request. The method request, I need to specify that there is a name parameter being inputted. So in the URL query string parameter, I'm going to add a query string called name, and I'll say this one is required. Now, I am ready to test this API gateway. However, I don't know if you remember what I said about that Lambda proxy integration, but because API gateway sends its data into Lambda via automatically packaging everything up into a JSON payload, the name parameter may not be passed the same way as how I've done my tests in the first place. In fact, we're going to need to go and modify our code. We shall create a brand new test for this though. It needs to be sent from API gateway. So I'll configure a brand new test event here, and I am going to create this new test event and use an event template of API gateway AWS proxy. I will need to specify a name here, hello name API test. And you can see that the data there's a lot more data that is being passed. One of the important pieces here is the query string parameters. The query string parameter is an element, right, that API gateway is creating for us, and this is where it will add the name query string parameter that gets added with the value that I wanted to have. So in our code, we cannot just say event.name anymore. I'm going to need to say event.queryString_parameters.name, because this is where now that query string is located. So I'll save this test or create this test, and I'll go into my Lambda function, hello name, go into my Lambda function, and I'll modify it with my event.queryString_parameters.name. I'll save it and hit the test button. Go back to the top, and it now says, hello, John. So we're good. It should work with API Gateway. We've created our test. Well, the best way to know that is to go test it from the API Gateway console. Let's go there. In API Gateway, there is a test button right here. I'll use and input my name parameter, name equal Jonathan. I'll click the test button at the bottom of the page. I get the data back, latency was 21 milliseconds, and in the response body says, hello Jonathan. So API Gateway is able to invoke Lambda, and Lambda was able to get the data, the query string parameter name, from the event payload. The last step here is to deploy this API Gateway, because I'm not going to give access to the console for my users and them coming into here and doing this test themselves. I want them to be able to use a URL in there. So I'll click Action, deploy the API. I need to create a new deployment stage. You've learned these with Wes in our previous lecture. So today, I feel a little bit cowboy, so we're going to deploy right away in prod. Don't do that at home though. And hit the deploy button. I now have my invoke URL that I can copy and input my name parameter with hope this works. And what I get back is, hello, hope this works. So API Gateway I was able to deploy my API Gateway in prod, and then now any users that has this URL that want to pass this query string can now use my brilliant hello name application that will now be used from the entire world. No need to scale Lambda, no need to worry about API Gateway scaling. All of that is managed for me. That's the beauty of serverless here. So in our next lecture, Rick is going to introduce you to the exercise, which will take a lot of everything that you have learned in the last few modules and integrate them and do an exercise around Lambda.
Thanks to John, you should now understand the value proposition of Lambda and the idea of running functions in response to events. Lambda's pretty awesome, and we're going to use it in multiple ways throughout the rest of these exercises. As usual, we'll start simple and enhance our Lambda function as we progress through the exercises. Whenever you use Lambda, you always need to think about what it's going to do and what it's going to interact with. In this one, we're going to replace API Gateway, the mock you built earlier, with a function that returns a temperature. Now, this doesn't make any real difference to our website, but what it will do is create a base from which we can add advanced functionality a bit later on. Once we have this mock Lambda in place, swapping out the code for more elaborate functionality, it's easy. We know we want to return a temperature, but what about the other thing we need to consider? What will Lambda interact with? Well, often when you write code, you might need to debug and push information to a logging system. As John talked about, we have CloudWatch for this. So naturally, that is one service that our Lambda function is going to need to interact with. We call that an execution permission. But there's even something else that we have to consider. API Gateway needs to wake up Lambda, but Lambda is not executing API Gateway, right? So we need something ever so slightly different here to wire this up correctly. We need an invocation permission on Lambda to say that it can be triggered by API Gateway. Now, of course, we could put the permissions on the API Gateway end and say that it is allowed to wake up Lambda. But for this lab, we're just going to create an invocation permission on the Lambda function because it's super easy to do in the console. So, once you have your Lambda function that returns a temperature, regardless of city, mimicking what you had with the API Gateway, and it has permissions to write logs and be awoken by API Gateway, we can test it in our front-end website. I hope you're starting to see the big picture here, piecing together serverless components on top of each other to create an end-to-end solution. Naturally, we need to make this work with real data instead of dummy data, but all in good time. Let's get this Lambda thing working first. Good luck with this, lab. I think you'll like Lambda. It's really cool once you start working with it.
Hi, welcome back. In this portion of the class, we're discussing the serverless NoSQL solution on AWS called Amazon DynamoDB. Together we will discover how DynamoDB service stores data, sorts, and completes scans and queries. Amazon DynamoDB makes your life easier by offering a simple and cost-effective way to store and retrieve any amount of data and serve any level of requested traffic. Listen, we are talking about millions and millions of requests here. It's important to understand the foundational concepts of DynamoDB, such as partition keys and sort keys, as well as local and global secondary indexes. That was a mouthful. Okay, let's start with the basic concept of a table. Remember, we're not building a database here in the traditional sense. Instead, in DynamoDB, we call that set of information tables. A table is a collection of items, and each item is a collection of attributes. I'll tell you what, let's draw this out so that it's easier to understand as I explain the remaining things that make up a table. First is the partition key, which is a simple primary key composed of one attribute. In the case of our table, we are storing music data. Our primary key should be artist. You see that next to the partition key is a sort key. That should be a song title. When a partition and a sort key exist in a table, it is referred to as a composite primary key and is composed of two attributes. The first attribute, again, is artist. The next attribute is song title. Okay, so while this table isn't super useful yet, it will become useful when we add attributes. Let's think of some attributes to add that are music related. Well, chart number, let's see, that's pretty important. Genre, year, beats per minute. For creating playlists to match your speed, that's kind of important too. So all this data seems like it would be very helpful to know. So now let's add those attributes to the table that we've drawn previously. Wow, this table is actually starting to become useful. But now we need to figure out how this data will be queried to derive meaningful insights. Let's talk indexes. A secondary index is a data structure that contains a subset of attributes from a table. along with an alternate key to support query operations. A table can have multiple secondary indexes, which give your application access to many different query patterns. First up is a local secondary index. That's an index that has the same partition key as the base table, but a different sort key. So an example of a query that we could use on a local secondary index would be to say, let's find all of the songs, the #1 songs from a particular artist, one artist. A local secondary index is an index that has the same partition key as the base table, but a different sort key. A good example of a local secondary index query would be all the songs from a particular decade per artist. So if I have a favorite artist, all the songs from the 80s, all the songs from the 90s. That would be an example of a query for a local secondary index. A global secondary index is an index that has a partition key and a sort key that can be different from those based on the base table. So an example of a global secondary index query could be all the #1 songs from a particular artist, or all of the songs of a particular genre. Doesn't matter what artist produced them. I want you to pause and consider for a moment how you will use DynamoDB. The secret to a successful deployment is to develop your application first and determine what your queries will look like. Then design your tables to best serve that data. Next, let's review a bit about performance. Provision throughput is represented in units of read and write capacity. There are several options to manage this. First is the ability for you to provision throughput, again based on read and write capacity units. There are a number of ways for you to configure this setting. Be sure to use our good friend Amazon CloudWatch to help guide you with your decision to increase or decrease. Next, you can use the on-demand mode for DynamoDB. This will help you get up and running quickly without much concern to performance configurations. And then auto-scaling. Auto-scaling is a way for you to run a more forgiving type of DynamoDB environment. Auto-scaling allows DynamoDB to scale based on demand, much like you could with EC2 for compute. As far as performance goes, these tools are largely automated since it's a managed service, which is really nice for you. In our next video, I will show you how to create a DynamoDB table and enter items into it to make it more useful. Thanks for watching. In this demonstration, we're going to build out an Amazon DynamoDB table, and then we're going to run a query against it. So let's get started. At the AWS Management Console, we'll go ahead and look for DynamoDB in the search bar. It pops right up. Click. And then I'm presented with the service front page. Now there are some learning opportunities here, but again, we're focusing on creating a table. So I'm going to click Create Table. For our table name, we'll put music. The partition key will be artist. And in this case, I'd like to add a sort key because artists could have more than one song. Typically they do. So let's go ahead and make the sort key song title. Great. Now let's scroll down. We could select the default settings. And as you can see on the screen, it sets it up with really no fuss about performance or any of the other parameters that you would typically have to set. It just gets you up and running. In this case, I'm going to deselect the default settings. And that's so I can show you the different areas that you could configure for DynamoDB. Scrolling down, you'll see that you can add secondary indexes. By the way, if it's a local secondary index, which this would be, this is your one and only opportunity to add it. Read and write capacity mode. We can choose whether we want this provisioned or if we want it placed into that on-demand, which remember is a very forgiving environment for us to run our DynamoDB in. In this case, we're going to stick on the free tier and use provisioned at 5 read and 5 write capacity units. Autoscaling is next. You'll notice that you can autoscale your read and your write, one or the other, or both. And you set this by the total utilization of the read or the write units. Scrolling down further, I have the ability to use a IAM role that already exists, or I can have the DynamoDB service create that for me. Scroll down further and then enable encryption at rest. You can select encryption settings for your DynamoDB, default or KMS. I'm going to just review my settings here. And I'm going to click Create. The table is being created, and it takes anywhere from 1 to 3 minutes on average. Now that the table's been created, I'm going to want to add some items. So let's take a look at the Items tab. I'll click on the Create Item button, and a window appears. This allows me to enter the values for artist and song title. So for artist, I have a favorite artist of mine, and that is John. My favorite song of John's is the Maple Syrup Blues. Okay, I've added my artist and my song, and now you'll see that the item appears. I'm going to add a few other items to the table, and then we'll come back. All right, now that we have all of our items populated in the table, I'm going to run a query. So I'm going to click the pull down. It says scan currently, but don't worry, there's a query under that. We click query, and we're going to set our values to run this on. You notice that the partition key is artist, the sort key is song title. So in this case, I'd like to say that I want to see all the songs written or sung by Evan. I place him in the key for the artist, and I click search because I don't need to enter a specific song title value because he has many songs that he's written or sung. In this case, all my AMIs live in Texas, and S3 Rhapsody are Evan's 2 hits that I have populated in the table. All right, so that was how you build out a DynamoDB table, enter items, and run your first query. Well, that's it for the DynamoDB demonstration. You're going to be able to apply what you've just learned in the exercise that Ricky's put together for you. I'll see you in future topics.
Hi there. I just want to introduce you to the Dynamo lab that you're about to do. Now, if I can, I'd like to set your mind at ease first, because many of you may be database wizards, but I would imagine that a lot of you aren't, and might feel a bit daunted when Adam was talking about provision capacity, local secondary indices, sort keys, and compound keys. Please don't worry. You really don't need to know all of that to complete this lab and actually take advantage of serverless DynamoDB. In fact, if you're new to Dynamo, and for purposes of this lab, you could choose to think about DynamoDB more like a tiny little spreadsheet. Bear with me. Try and visualize how simple it could be to look up a temperature by city. One column of unique city names, one column of temperatures. The first column, city, is what you'll query on to get the temperature back. See? The world's simplest DynamoDB data structure. No index in sight. Sorry, Adam. We don't need them. Not for our cat weather app. Seriously though, Dynamo is really powerful. It's used by some of our largest customers and can handle billions of interactions. It can do transactions, auto-scaling, and you can even design really complex schemas and build incredible real-time serverless applications with it. So just because we're using the world's simplest schema for our tiny little cat app, don't think for a second Dynamo isn't legit. It's a professional, enterprise-grade, battle-hardened serverless NoSQL database. It has single-digit millisecond response times. I mean, what do you think Amazon.com runs on? So, I hope you enjoy working with Dynamo in this exercise. Remember, if you get stuck, forums, forums, forums. Oh, and once you have DynamoDB working, we'll simply adjust the Lambda you did in the last exercise to query it, and then check the website to make sure you can get a temperature back. But that's all pretty easy. And I've added a load of notes in the exercise guides for you. Anyway, hope you enjoyed creating your first NoSQL serverless database. Best of luck. Welcome to week 4. Wow, you made it all the way through to the last week. Congrats. We're almost there, the home straight. Now, before I tell you what I have in store for you on your last week, let's reflect on what you've learned and built. We covered DynamoDB, IAM, CloudFront, how to set up an S3 website, Lambda, and Lex. But what have you actually built? You now should have a working, serverless, data-driven website that solves a critical business need, knowing if it's too cold for your cat. Well, if you think about it, this app has a lot of serverless topics all stitched together. So I think that's pretty cool, considering we haven't had that much time together. So what do I have in store for you now? Well, I'd like to take the user experience to the next level by integrating the conversational functionality of Amazon Lex with your web app. Now, normally, to do something like this, we would need to introduce more services like Amazon Cognito or Amazon Poly, but we're not going to do that. We're going to cheat. We're going to leverage the innate features of a browser to demo a voice user interface on a web page. The idea is that you can hit a button on the website and start talking to Lex. Lex will respond to the browser, and the browser will convert that text back to speech. Cool, right? Remember, there's no code to write. We've written all that part. All you need to do is adjust the backend API gateway to point to a different, new Lambda function that allows us to pass messages between the user and Lex. So by integrating Lex and voice in the browser, we turn a basic data-driven weather extraction app into a fun conversational voice chatbot in the browser. Now, is making Lex fully data-driven and truly conversational easy? Not so much. But lucky, we have John, and he's going to spend most of this week discussing how to make Lex smarter, and he's going to use what we call validation hooks. And once he's done, I'll come back and talk about the lab, where you get to build that into your website and have your very own mission-critical business app, Cat Weatherbot. All fully serverless, of course. Anyway, I hope you enjoyed this last week's videos and exercises, and I'll see you at the end.
In week 1, I told you about Lex, and we had some fun in the console with a simple book trip bot. There are a few components that I did not discuss during that lecture, and most of it had to do with the Lambda integration. Now that you know about Lambda, it's time to discuss the interaction between Lex and Lambda. Let's take a look at our book trip bot again. It has 2 intents, book car and book hotel. We're going to go on book hotel. When a user enters a utterance, Lex chooses the right intent and then uses prompts to ask questions to the user to fill every slot of the intent so it can be fulfilled. So we can see many slots are at the bottom in here. As I mentioned, in the Lambda integration wasn't discussed. This includes the Lambda initialization and validation as well as the fulfillment. The reason to use Lambda for fulfillment is the same reason as to why you will use Lambda to replace servers. You only pay while your Lambda function is running, and it's serverless, which means you don't need to manage the components behind Lambda, and you can concentrate on your backend code. In this bot example, I will want the Lambda function to include the pricing for the hotel booking and car booking at the fulfillment time. Let's first look at validation though. When the intent is configured to invoke a Lambda function as initialization and validation code hook, Amazon Lex invokes the specified Lambda function on each user input after Amazon Lex understands the intent. If the intent is not clear, Amazon Lex can't invoke the Lambda function. Why would we want a Lambda function invoked for every single utterance or prompts? Validation, of course. But don't we already do validations in the case where we select restrict to slot values and synonyms in a slot type? As an example right here, restrict to slot types. Well, yes, but sometimes we don't control the slot because it's a built-in slot. As you can see the slots down here, the Amazon ones. Let's take the location slot of the book hotel intent as an example. What if we only had hotels in a very specific list of cities? We can't change the Amazon US city slot type to include only the values that we want. It's a built-in slot type. That's where Lambda comes to our rescue. It allows us to extend the capabilities of the bot. Let me show you what happens when I book a hotel in Moscow right now. As you can see, it prompts me back to supply a city. Let's supply Moscow. It continued on. As you can see, this city is accepted. However, what if it wasn't one of the cities we had hotels in? Well, there's no validation here. Of course it will let me go. We will need to fix that. Let's finish this iteration with the bot to refresh your memory of what happens across this entire bot. So in here, what day do you want to check in? I'll answer tomorrow. How many nights will you be staying? 5. And then finally, what type of room would you like? Queen, king, or deluxe? Queen is good for me. I get a confirmation prompt. Okay, I have you down for a 5-night stay in Moscow starting on 2019-02-21. Shall I book the reservation? Yes. And I get back the normal fulfillment that you have seen in the past. To add validation, we first need to create a Lambda function. I will be using a blueprint as the Lex team was nice enough to give us a template for the Lex sample bot that we already used. From the Lambda console, I'll click Create Function. I'll select Blueprints and then search for Lex. I can see that the Lex book trip Python blueprint is in here, and that's the one I will use. I'll click Configure at the bottom of the page, and I'll need to supply a name for it. I'll give it a name like Lex book trip. And then I will have to choose a role for my Lambda function to be able to send logs to CloudWatch logs. Let's not look at the code yet, though. I'll create the function. Let's go back to the Lex console to modify our bot to send this traffic towards this Lambda function. In the Lex console, I will modify both intents to use this Lambda function for initialization and validation as well as fulfillment. So in the book hotel, I am going to go to the section of Lambda initialization and validation, select that checkbox, select our Lex book trip function, and I'll get this pop-up. That is asking me to allow Lex to call our Lambda function. Else, Lex won't be able to send that request to it. I'll click OK here. Let's do the same with the book car intent as well as the fulfillment in there. I'm starting the build now for my change to take effect. With the power of recording, I will skip ahead for the build to finish. Okay, it's ready for testing. Let's try the same example as earlier. Book a hotel. What city will you be staying in? Moscow. And I get this prompt. We currently do not support Moscow as a valid destination. Can you try a different city? Doesn't seem to want to let me go forward with this city. That is normal, as Lambda is now doing the validation and only allows a specific set of cities where we have hotels. You are welcome to look at the Lambda code if you feel comfortable with Python. It will explain a few things that are in here. However, instead of looking at the code itself, I will explain to you the flow of the data passed back and forth between the client, Lex, and Lambda. Let me explain it to you in a diagram now. As you can see in this picture, I have a user on the left-hand side, Lex in the middle, and Lambda on the right. The user inputs book a hotel. That is sent as a utterance towards Amazon Lex. Amazon Lex will parse the data and send it as an input JSON to Lambda. Lambda will do its validation and then return some output JSON statement towards Lex. And Lex will finally send some of that response back towards the user, which will probably prompt for in which city by that point. So the user can now enter Moscow at that time. Now, remember that the first step is the data sent from the client into Lex. So if I roll back a little, I have book a hotel, the data gets sent into Lex. Let me restart this test that I have here by clicking on Clear Chat History. I'll book a hotel. Let's see what is sent into Lex in this case. Because remember, I have the utterance that is now sent into Lex. Let's take a look at that JSON payload. This is the data that is being sent. You can see that there is the client sending a post towards our book trip in the alias latest and for a very specific user. I will come back to this user a little bit later in this lecture. I also can see the input text data, book a hotel. That is what will be sent towards Lex. The next step is for Lex to send that data to Lambda and input JSON. Let me switch back towards the input that was sent, and then this is it. A lot of information is here, but let's take a look. The invocation source is set to invocation source, the dialog code hook. This is how the Lambda function knows that it's supposed to do validation of the entries and not do fulfillment, as that will be the other option that we will see later. We can see the bot name, book trip, in there in case that this same Lambda function was used for more than one bot. The current intent name is pretty important though, because I'm reusing that same Lambda function for book hotel and book car. It's currently set to book hotel, which means Lex was able to figure out that we wanted to book a hotel from the text that was sent. That didn't seem that difficult. All of the slot types are currently set to null, as you can see. So Lambda doesn't need to do much validation at that point. So to itself, it doesn't really do anything there. However, it will need to send some data back towards Lex. Now that Lambda has done that processing, which means that it's essentially nothing this time around, as it's only the initialization, it will send data back to Lex. Let's take a look at it. This is how a response looks like. It needs to be a dialog action type. I will have a dialog action of type delegate. This means, or that directs Amazon Lex to choose the next course of action based on the bot configuration. That next course of action is to prompt for the first slot, which is the city. Right? If we look at our configuration of our bot, we can see that the first slot is the location. So it needs to say, what city will you be staying in? So that data will be sent as a Lex response back towards the user. Let's take a look at what that looks like. What I get is, what city will you be staying in, sent back towards the user, as you saw inside of the console. I'll now go back into my Lex console and write Moscow. Let's go back to our diagram now. What did I just do? Well, I've just sent a prompt into Lex. I just fulfilled the slot. It is the exact same 4 steps that will need to happen again here. Let's take a look at all of those 4 interactions payload, and then we're not going to really come back into this diagram now. So the next section is the client sends Moscow. As you remember, the input text is set to Moscow. Next, Lex needs to send that data into Lambda. So the data that is now going to be sent is towards the current intent name book hotel, and then the location is now going to be set to Moscow. Lambda can now process the city and validate it against its list of cities where there are available hotels. In this case, Moscow isn't part of it. Here is what Lambda sends back. It will say dialog action type of type illicit slot, which informs Lex that the user is expected to provide a slot value in the response. The intent name is specified, book hotel, and the location is now set back to null, as it wasn't valid, and the slot to illicit is now set to location, which is the important one. We now tell Lex which slot to prompt back the user for. However, instead of using a built-in message, we also supply a message to the user. We currently do not support Moscow as a valid destination. Can you try a different city? That is what will be sent towards the user. That data is now sent back to the client. Here's what Lex sent. We currently do not support Moscow as a valid destination. Can you please try a different city? This time around, the client is ready to choose a different city. Let me pick another one, Chicago. Oh, it seems it let me through. Let's go and take a look what happened there. The client sent Chicago. Input text, Chicago. Lex sends the data into Lambda. This time around, current intent, name book hotel, and in the location, Chicago. Nothing really has changed in this case. Now Lambda will need to validate this city. Chicago is a city where we have a hotel, so this passes the validation. This is what Lambda replies. Dialog action type, delegate. A delegate type as we want Lex to continue its processing to the next slot. As you can see, Lex is now asking for the check-in date. What day do you want to check in? Yes, it's the next one in the order. If you remember well, I have the location, and then the number 2 is check-in date. So that's why it used that prompt. We've now seen how validation works between Lex and Lambda. In our next video, I'll go over how to do fulfillment with Lambda and the usage of session attributes. I'll see you there. In our previous lecture, we used Lambda to validate slot values. I will continue from that example to discuss fulfillment and session attributes. I'll start by interacting with the bot and fill all of the slots this time. Book a hotel. What city will you be staying in? I will select Chicago. What day do you want to check in? Tomorrow. How many nights will you be staying? 5 nights. What type of a room will you like? Queen, king, or deluxe? Queen. I'm now getting a prompt confirmation, but something has changed here from the time where we didn't have Lambda integrated. If you look, a price is provided for this hotel. Don't worry though, it's just a generated price randomly. It's not that expensive to stay in Chicago. Well, I hope not. To understand how this happened, you will need to understand another concept called session attributes. They contain application-specific information that is passed between a bot and the client application during a session. Amazon Lex passes session attributes to all Lambda functions configured for a bot. If a Lambda function adds or updates session attributes, Amazon Lex passes the new information back to the client application. Session attributes can also be used to add more information in the prompts to the user, as you can see it here. How long are those sessions being kept? Well, if we go under the settings of our bot, under General, you will find the session timeout here. We can see that it's currently set to 10 minutes. You may also be wondering what constitutes a user to Lex. Well, when a request is sent to Lex, a user ID is also passed, and that's what Lex will use as its key to associate all of the session's attributes until the timeout is reached. Your application is responsible for generating it. When testing with the management console, it is generated automatically for you. That's why we never had to worry about it. Back to our interaction with the bot, we just sent the last piece of information to Lex. That was the last slot to fill, which looks like the following. As you can see, it is a post for Queen as my bed, but you can also see the user ID right here. That's what I meant by the user IDs being sent into Lex. Lex then sends that information to Lambda. The Lambda function will need to realize that all of the slots have been filled, as you can see it right here. And it will need to use a session attribute called current reservation price, it's up to the Lambda function to decide that, to store the price of the hotel. Lambda will send back that data to Lex as you can see it. It uses the delegate function to let Lex continue with its processing, provides all of the slots again. But there's something a little bit different here. The session attribute is currently set to current reservation price $1,195, which is what we saw in our prompt. Let's take a look at the prompt that will be using this information here. Back into our editor, I will go towards the confirmation prompt. Clicking on the little gear icon, I can see the price of this night, amount of night stay in the location from check-in date is square bracket current reservation price. As you can see, there's two prompts. One of them makes use of those square brackets referring to that current reservation price. This is the way to invoke session attributes within a prompt. The client can now confirm that the entry is correct at that point. So I will type yes here. The input data for this is going to look like the following. As you can see it, input text equal yes. This time, Lex will invoke the Lambda function with a different invocation source. As you can see it here, invocation source, fulfillment code hook. That is how Lambda knows that it's supposed to fulfill this. It can use all of the slots data to do the booking in the backend system. Lambda will need to send one last dialog action back, and that is of type close, with the fulfillment state set to fulfilled. A message can also be supplied, or the response section of the bot will be utilized. In this case, we use the message. Lex will send that message back to the user, and then now our interaction with our bot is now finished. However, the session is still alive. It's set to 10 minutes. And if the user wanted to continue booking a car, there are some slots that are already filled from our previous interaction with the bot during our book hotel. Let's test that out. Let me book a car. As you can see, it asked me a question. Is this car rental for your 5-night stay in Chicago around that date? It found that information. If I look at the summary, it even figured out the pickup city Chicago, and it figured out my pickup date and my return date and did the math for me. This is done using the Lambda function and the session attributes that can be passed between all of the different intents. I'm inviting you to explore the code to see how this was done if you're familiar with Python. Soon, you'll put to use everything you have learned about Lex into an exercise. Thanks for watching. If you want to extend your bot further, let's see how I can integrate different channels with my Lex bot. This is done using the Lambda function and the session attributes. I'm inviting you to explore the code to see how this was done if you have the time and if you want to read some Python code. Now that I have a bot that is fully tested, I can publish it and show you the channels tab. On top of easily integrating Lex in the web UI like you will do in the next exercise or in your mobile application via the AWS Mobile SDK, you can integrate your bot with Facebook Messenger, Kik, Slack, and Twilio SMS. Let's see how to do that with Facebook Messenger. First, we need a name. I'll input serverless chatbot. Then, I need to fill which alias I want to associate to my Facebook page. I'll use prod that we've created before. Then, I need to select which key management service key I want to use to encrypt all of the data that I will use below. I'm going to leave it as AWS Lex. I need to input a verified token that I will use and reuse it, in fact, on the Facebook developer portal. I'm going to use the very secure token. It's a very secure token. For the other two parameters, I need to go on Facebook to get those. First, I will create a Facebook page. I hit the Create button and select Page. I will use community or public figure by clicking the Get Started button. My page is going to be called Serverless Chatbot, and then the category is going to be Just for Fun. And I will click Continue. I'll skip the next two steps out here because I don't really need that here. Now that I have a page, I will need to jump over to the developer portal of Facebook, a little bit different website. In here, where I'm already logged in, I'll create a brand new application by clicking on the My Apps menu at the top and clicking Add New App. For the display name, I'm going to use Serverless Chatbot. They don't need to match, but it's all right. I'm going to make them match. I'll click Create App ID. I'll confirm that I am not a robot, and I'll click Submit. Going under the settings, under Basic, I am going to find my app secret. I'll need to click that Show button right here to display it. I'll take this app secret, go back to Amazon Lex, and enter it as my app secret input here. Next, I'll go back to my developer portal in Facebook. I will go under the products page and I will add Messenger, and I'll set up Messenger here. I'll go under the token generation and I'll select the Facebook page that I created called Serverless Chatbot. I'll continue as myself. Now, this gives me a page access token that I'll copy and paste back onto my Lex console. I now have all of the data that I need to create my channel in Lex. So let's activate it. I will get an endpoint URL. I will copy this endpoint URL that I will then use a little bit later. So, still under the developer portal, under the setting of Messenger, I'll go under webhooks. I'll click the Setup Webhooks button, where I will input this endpoint URL that I have just copied from the Lex endpoint. Then I need my verified token. If you remember, that was the very secure token. Then I need to specify subscription fields. Those are messages, messaging postbacks, and messaging opt-ins. I'll click Verify and Save, and it seems like it worked. The next step is to subscribe under my webhooks, subscribe my serverless chatbot page to this application that I have right here. So now that it's subscribed, it's time to test the chatbot via Facebook Messenger. In my Facebook page, I will add a button by clicking the Add button. I'll select Contact You, send the message, click Next, select Messenger, and hit Finish. Now, this Send Message button allows us to send a message to the chatbot. I'll test it out, so putting my cursor on top of Send Message and clicking the Test button. My chatbot is now available via my Facebook page. So let's do a quick chat. Book a hotel. What city will you be staying in? Huh, that sounds familiar. It looks like I'm interacting from Facebook this time, all the way back to our bot. Exactly, that's how channels work. It's an integration between a few different components, Facebook, Twilio, SMS, Kik, and Slack towards your bot. Soon, you'll put to use everything you have learned about Lex into an exercise. Thanks for watching.
John has covered a lot of ground with Lex, which is awesome. So now we can leverage that information to help take our website to the next level. Firstly, we want to make our Lex bot smarter. Because currently, if we ask our chatbot, can my cat go outside in banana? It's going to say, you want to know if your cat can go outside in banana? Got it. Far from ideal, right? Well, by creating a Lambda validation hook that John talked about, we can make Lex query Dynamo directly and get temperature information back. And if for some reason it doesn't understand the city, well, it'll just prompt them for a different location. What you'll notice after implementing this validation hook is that the very basic chatbot you created in the Lex console in week 1 suddenly will become a lot more lifelike because it's actually making decisions during each conversational interaction. Now, it's all well and good having a smarter chatbot, but how are we going to publish it and help other cat owners around the world solve such pressing problems? We can't just keep using the Lex console for this, as that's only for developing. We could have considered wiring this up for Alexa because it's the same engine and that would have been a relatively easy export. We could have gone with what John showed you, one of the Lex channels like Facebook or Slack. The challenge there though is that's just text. And I wanted to have all of you create a voice-enabled one. So for this lab, we're going to build a web-based, voice-enabled user interface for Lex using JavaScript. We could have used Amazon Polly and Amazon Cognito for some of this, but we really want to save those services for another course. Instead, we're going to cheat, and we're going to use a browser to convert speech to text and text to speech, and simply proxy the message back and forth to Lex via API Gateway. It will feel like you're having a natural conversation with your browser. And don't forget, you'll need to provide all the right permissions for both this proxy function and the Lambda validation hook. Fear not, all of that information is in the exercise notes. After we build our Lambda proxy and mimic Lex payloads with test cases, we can go over to the website and ensure that we can hold down a, should we say, conversation with Lex via the browser. Then at last, we will establish if our cat can go out or not. So to recap, number 1, we're going to create the validation hook and set your permissions. 2, you're going to create a Lambda proxy behind API Gateway, set its permissions, and test it in the console. And finally 3, you're going to go over to the web-based voice-enabled application in the browser and test it. All the code is written for you. All you need to do is follow the exercise instructions. Now, as a final thought, I wouldn't trust Lex to know if I should let my cat out or not, as we're not using real data, we're using random temperatures in the database. If you want to know how to work with Amazon DynamoDB and real-time data, well, that's something we can look at in a different course. So, off you go. Best of luck with your final exercise. And if you do get stuck, where'd you go? That's right, the forums. Have fun. Wow, you made it. You got your cat weather app working, right? Awesome. So I'm hoping at this point, you can think about how you can take what you've learned into the real world. Now, even if you don't use all the products in this course, we've covered enough bases in the time we've had together for you to get some use out of this. There are a lot of people that go into making a course like this, So I'd like to acknowledge that and thank everyone for helping make this course a reality. Don't worry, I'm not going to do an Oscars speech and thank everyone by name. You guys know who you are. Thanks. So where do you go from here though? Well, I'm going to ask you to refer to the course notes because that's the best source of up-to-date information. That will tell you about getting access to resources and provide links to more sources of information. We're preparing new courses all the time, and each time we produce a new course, we learn something new just by going through the process. But we're always looking for ways to make it better for you guys. So if you have suggestions, ideas, or even criticism or compliments, or if you just want to say hi, bring it on. Dive into the forums. We are listeners, and our goal is to provide the best learning experience we possibly can. So, I'll let you guys go now. Keep an eye out for our upcoming courses, and I look forward to seeing you again. Thanks. Bye, y'all.